For this learning plan, we are talking about ROM. Read-only memory has several characteristics. It is non-volatile, and this means that the information is not lost when the power is off. In this sense, we could call it secondary storage. Secondly, ROM is read-only. It can't be easily erased or written over on a continuous basis the way that RAM is. And it's used to store information that must be present in order for the PC to start running and function. Now, your processor needs to communicate with various devices in the system, and precious clock cycles would be taken up if this communication were coordinated by the processor itself. As we've mentioned before, the chipset handles much of this communication. The two main chips of the chipset each have specific tasks. The North Bridge chip acts as the primary bridge between the CPU and the rest of the computer. This chip also used to function as the memory controller chip, but this function has now been moved into the processor itself. So today, the North Bridge deals with high-speed interfaces such as RAM and video card. Another chip in the chipset, the South Bridge, works with slower devices such as the USB ports and the hard drive controllers. The North and South bridges are like traffic control on highways. They coordinate communication to and from the processor and other system devices over the various computer buses such as the front-side bus and the address bus. The processor doesn't automatically know how to talk to each different component. It relies on additional support programming loaded into memory that tells it about each particular device. This basic programming is called Basic Input-Output Services, or BIOS. The ROM BIOS chips fixed onto the motherboard store the instructions or programs that tell the system how to get started and how to send to or retrieve information from a particular component or device. Each of these hundreds of little programs is individually known as a service, and they run the keyboard, your drives, monitor and video subsystem, and other basic devices in the system. We call these programs firmware instead of software because they are stored on hardware chips and they don't usually change. There are different kinds of ROM BIOS. The first type of BIOS is the programs that talk to the most basic devices. This is System BIOS, and it deals with two types of hardware, the changeables and the unchangeables. The unchangeables are those system devices that are common, necessary, and never change. This includes the keyboard and the system speaker for beep codes, among others. The changeables are those devices that are common, necessary, and may change on occasion, such as RAM, hard drive, and whether or not you have a floppy drive. In each case, these are devices that have been found in systems for years, so their presence is expected, and they are found on nearly every system. They are also necessary, as we couldn't use our systems as we've come to expect without them. We can't use a PC without RAM or a processor or keyboard or some kind of permanent storage device. The information for the unchangeables is found on the ROM BIOS chip itself. But what about the information on the changeable devices? We don't want to be changing or upgrading or rewriting the BIOS chip information every time we want to add RAM, or swap out the hard drive for something bigger, or replace a CD drive with a DVD drive. There's a place we can store the changeable device information in detail, and that's in a chip called the CMOS chip. CMOS stands for complementary metal oxide semiconductor, which is the material the chip is made of. But no one wants to say all of that all the time, so we just call it CMOS. CMOS does not store programs as BIOS does. Instead, it has data that's read by BIOS in order to run its programs for a particular device. It stores information such as system date and time, hard drive configuration, keyboard and mouse types, port settings, security information, power management settings, and so on. This information gets updated through setup. Often you'll see it referred to as CMOS, CMOS setup, or just setup. I tend to use those terms interchangeably. To access this information, press the indicated key as the system is booting before the operating system starts to load. On newer systems, this key may be the delete key, insert, escape, F1, F2, or F10, depending on your computer system and your BIOS CMOS manufacturer. There are three main manufacturers: Phoenix, Award, and AMI, or American Megatrends. Between these three, they provide the BIOS and CMOS setup for most PCs in use today, although you may occasionally find a system with proprietary CMOS. Take a look at the main menu screens for each of these CMOS programs found in your text. You'll be looking at those in lab. Now, CMOS, because it is editable information, is actually stored on a special SRAM chip known as NVRAM, or non-volatile RAM, which, if you think about it, is an oxymoron. If it's RAM, it's going to lose its contents when the power is off. If it's non-volatile, it's going to maintain its contents when the power is off. But because it is RAM of a kind, it needs power to maintain its contents, which is commonly supplied by a battery somewhere on the motherboard or in the BIOS or CMOS chip itself. Now, what about information on devices that are not included in the BIOS or CMOS chips? There are some options. Some devices come with their own ROM BIOS that tell the system how to use it or tell the device how it should function in a system. The primary example of this is a video card, which has its own BIOS chip for internal functions. For other devices, we use device drivers to instruct the system on how to manage them. Device drivers are small programs that are stored in a file on the hard drive. They contain all of the commands necessary for the system to talk to and use that device. On boot up, they will load into RAM memory so they're available whenever that device needs to be used. So some devices that come with drivers include things like printers, video cards, expansion cards such as network cards. And you can usually get drivers or driver information on a particular device right from the manufacturer's website. Remember that if the driver is missing or corrupt, its associated device will not function. Your system will not even see that device. Driver information, along with all other information about the system, is stored in the operating system configuration files. In Windows, these files are known as the registry. This information is accessed, updated, deleted, or changed by using either Control Panel or Device Manager. If you add a printer through Control Panel or delete an old video card driver in Device Manager, you are actually making changes to the registry as well as updating the system's device configuration information. If the information about an unchangeable device needs to be updated for some reason, this means that the information on the BIOS chip needs to be updated. Most motherboards today contain a chip known as a flash ROM chip. From the appropriate website, you can download and run the programs that will update the information in BIOS so that you can use some of the latest technologies. There's one more BIOS function we need to discuss, and that's the third type of BIOS, known as Startup BIOS. There is a chip on the motherboard that stores the startup routines and post or power on self-test. This is a series of little programs that the system runs each time you turn on the power to see if everything is present and functioning properly. So these tests look for power, the processor, a keyboard, video of some kind, RAM, and drives. If everything is present and accounted for, many systems will respond with a single beep. If there are no beeps or more than one, this generally indicates that something is wrong. Booting comes from the phrase to lift yourself up by the bootstraps, and it means that the system brings itself to a working state without user intervention. There are two types of boots, the hard boot and the soft boot. A hard boot, which is also called a cold boot, is when you turn on the PC using the power switch. A soft boot, or warm boot, is when you press Ctrl-Alt-Delete to restart the system. Hard boots are more stressful on your system than soft boots. This is because you are sending a surge of power through all your devices when you apply power. If the system is already on, you can usually use a soft boot to restart. You can also use the reset button if this is found on your machine. This will actually restart the system earlier in the reboot process than Ctrl-Alt-Delete will. The reset button will usually work in situations where Ctrl-Alt-Delete doesn't restart the system, such as when your keyboard and mouse are locked up. If neither of these soft boots works, you must do a hard boot. Each BIOS has a series of beep codes that indicate specific problems. You may hear several beep codes during labs done during the semester. Sometimes Post will return a text message error instead of a beep code. There's a reason it uses one or the other, and it has to do with how the system wakes up as it's booting. When you first press the power button, the power supply provides the proper power to the system components. The processor is the first device to wake up. It immediately sends a built-in memory address, which is the first line of the post program located in system ROM. The system clock begins to generate clock cycles, or clock pulses, as the power is applied. The CPU initializes itself by resetting its internal values. It then looks for the first instruction in the ROM BIOS program, and the post is run. Post will check the BIOS program and then test the CMOS chip. The system battery is also checked. The processor is tested and further initialized. Now, up through this point, there is nothing on the screen. All of this happens even before there's any text showing up on your screen. And if there are problems, they are indicated by beep codes. Next, Post checks the video controller card or chip. If it's working, It now uses the monitor to display its progress. From this point on, if there is trouble, it usually displays error messages. Next, RAM is tested and counted. Hardware devices are inventoried and compared to their configuration information. The keyboard is checked. Floppy, hard drive, and optical drives are checked. You can tell when these are being tested because you'll see that the lights on these devices will flash or flicker. CMOS setup is run at this point if it's requested by the user. A startup or power on password may be requested during boot up to allow completion of the startup process. This is something set in CMOS to restrict access to certain parts of the configuration or to the entire system itself. After all of this is done, the post sends control to the last BIOS function, which is loading the bootstrap loader. This is a little program, just a few dozen lines of BIOS code at the end of post that looks for your operating system. Depending on the boot sequence set in CMOS, the bootstrap loader may look on a floppy disk, a hard drive, an optical disk, or USB device to find operating system startup code. Any of these media that have a functional operating system are called bootable disks or drives, or sometimes system disks or drives. Once the operating system is found, BIOS turns control of the system over to your operating system, but it still keeps its services ready to assist your OS in talking to the hardware devices. That concludes our discussion of BIOS.